Okay, we are going to see more of the logarithms proofs, but please don't forget to subscribe to the channel. Now, we have an interesting proof here. It says, show that if x is equal to this, and this, then x plus y plus z is equal to this. I think it's a common proof. You have seen it somewhere maybe, so I'm going to handle it. The properties we are going to use both for indices and logarithms are here. So we know that this property, log of p base q equal to r, means that we get q power this will be equal to this. Also numbers of the same base, if they are multiplying, we add the powers like you see there. And said if powers are the same, I mean if bases are the same, it means that powers are also going to be equal. Now let us come to this one here. So there you see, we are going to first apply this property here. It means that now a power x will be equal to that as we have seen from this property. So from here, my a power x is equal to bc. We call this equation 1. Then from here, b power y is going to be equal to ac, equation 2. Then from here, c power z is equal to ab, and this will be equation 3. So as simple as using this property here. Now from there, what we are going to do, we try to create all these. It's that in our proof, we don't have anything like A, B, C. So we eliminate A, B, and C. How are we going to eliminate A, B, and C? We make sure that we express these things in terms of one base, and we create those bases, and we get the powers. So we put all x, y, and z to be powers, then we eliminate A, B, and C. How am I going to do that first of all? I'm going to say, first of all, I get A divided by, I get equation 1 divided by equation 2, so that I can eliminate C. So it's going to cancel. So equation 1 divided by equation 2. So from here, then this is my equation 2. So B divides this over a C. Now I start this one, cancels. And from there, so that I'm going to cross multiply this and this. When I cross multiply, I have ax times a equal to by times b. So from here, it's that my ax plus 1 is equal to by plus 1. I say I want to create one base. Instead, I'm going to create b in terms of a and also c in terms of a, so that I can substitute them here. So how do I remove this power? By multiplying by the reciprocal both sides. So if I get x plus 1 over, I get times 1 over y plus 1, both sides will be equal to b. Now I also do the same thing. I get now a, I want to express a in terms of c, because I'm seeing c here. What I do, I get equation 1 divided by equation 3. So my ax over cz over ab. That's what our a is going to go. When I apply this here, I have ax times a equal to cz times a c. This will give me ax plus 1, numbers of the same basis. This is what we are talking about. This is power 1, then we are multiplying them, you add the powers. Equal to c power z plus 1. Now, I want to express it in terms of a. So I divide through I times 1 over z plus 1. Also this I times 1 over z plus 1. So this will cancel with this. So here I be adding a, the whole over z plus 1 equal to c. Now it's that I have what a is, I have what b is, I have what c is in terms of a. So from here, I know that from equation 1, my ax is equal to bc. So can I substitute them here? When I substitute them here, but I have now my ax equal to my b is here as ax plus 1 over y plus 1, then times c. My c from here is a x plus 1 over z plus 1. Now we say when we have number of the same bases multiplying, we add the power. So that's what is going to happen. I'm going to add this power to this power. So from there, so now my ax is equal to now x plus 1 over y plus 1, then plus. Now we add this power, x plus 1 over z plus 1. The whole of this, they are adding that power. Now, we start from there. We have the same base. It means that the same numbers over the same base means that the powers are going to be equal. Meaning that from here, this power is going to be equal to the whole of this. So my x is going to be equal to x plus 1, then plus over z plus 1. So from there, we start now, we have at least A and B. Now we are going to cross multiply and do that algebra to get this proof out. So I'm going first of all cross multiply to get the LCM, cross multiply this and this, we shall get into plus 1, then plus this x times this into y plus 1. The whole thing, we are, remember, we are dividing through with this times this, z plus 1. So, we start from here also. I'm going to cross multiply. So this is over 1. We are going to cross multiply like this. I have x into 2z plus 1. Then beside, I have it so there you multiply. So this times this we get xy plus x into now z plus 1 equal to this time this we get xz, get x z 1 xy x y plus 1. So now we also expand this. This times this we get xy z, this times this xy x z, or z x for x z, then this times this get x equal to what we have this side. We have x z plus x y plus x plus z plus this x plus y, then plus this one and this one get 2. Now we see some things cancelling. So this xz is cancelling with xz. xy is cancelling with xy. You see that also our x is cancelling with that. So this side we have xy z equal to this side we have x plus y plus our z then plus 2. Now if I take this 2 on this side, so now my x y z minus, if I bring to this side, equal to x plus y plus z as required proof. So I think you can see it there. So that's it, members. I will see you when sending more proofs about Logarithms. You like me to handle. See you.